Hey guys, happy Tuesday. As you know, reflection means the bouncing of light, and today we're going to talk about refraction, which means the bending of light. And the first thing I'm going to have you do is some exploring with refraction. So you're going to need a few things. You are going to need a pencil. If you don't have a pencil, it could be a pen or a marker or a ruler, but this item is going to get wet. You're going to need a clear plastic cup. If you don't have a clear plastic cup, maybe you have a glass cup, that will work. And then you're also going to need a penny. If you don't have a penny, it could be any coin. So go ahead and push pause and see what materials you can gather to use. All right, let's look at the refraction task, which is number 2 on Tuesday, April 14th. I'll go ahead and open this up. Okay, so the materials you're going to need, once again, clear plastic cup. Maybe it's plastic, maybe it's glass. Either one's going to work. Container of water. That would just be another cup of water. A pencil or a marker or a ruler or a knife, not a sharp knife, and a penny or any type of coin. All right, our task is that light travels in straight lines. Light travels at different speeds through different types of matter, otherwise known as mediums. Experiment with the materials to determine how the changing speed of light through different mediums, plastic, water, and air, affects objects. This effect is called refraction. So here are some guiding questions to help you as you experiment and observe with these materials. What does a pencil look like at different angles in the cup of water? Okay, so your cup of water that you need to use is about halfway filled because you're going to be putting things in the water, including your hand, and you don't want to put your hand in and then have it overflow and make a mess at your house. Okay, so what does a pencil look like at different angles in the cup of water? Maybe it's what does a knife look like? What does a marker look like? Okay, the second question, what does your thumb look like at different angles when placed in the water? Look at a penny or another coin from an angle while it is underwater. Poke your pencil at an angle into the water to try and touch the penny. Look from above. Did it hit the penny? And finally, place a penny at the bottom of the empty cup. Slowly pour water into the cup. View this at different angles. What do you observe? So, as always, it is an option once you have experimented or while you're experimenting, if you want to take a picture and post it to Seesaw just to share what you are learning about refraction. I know that a lot of times kids like to put their thumb in the cup of water and take a picture. They think it looks cool. Up to you. After watching the cool light refraction science experiment, the only thing you have left to do for today is to read the refraction of light reading passage and to answer 4 questions. Now, if you would like to hear me read it to you, that's fine. You can just continue watching this video, and I've recorded myself. If you want to read it on your own, no problem. You can read it on your own and answer the questions, and you can go ahead and stop the video now. I will see you tomorrow. Light is a speedaholic. It loves speed. It wants to move as fast as it can through anything that gets in its way so it can continue to shoot through the universe. Light normally moves in straight lines, but when it reaches something new, like a piece of glass or water, it will change direction to find the fastest way through. Just like you might change directions when you run from an empty field into a crowd. When light exits, it will bend because it's free to move how it wants to. This is called refraction. Have you ever tried to run against the wind? It's hard, right? It pushes against you. But if you run at an angle, you can keep moving fast. How about running through water? Even harder, right? The water grabs your feet and holds your body back. Like you, there are some things that light can pass through more easily than others. Light will move more quickly or slowly, straight or at an angle, depending on its medium. And no, that's not the shirt size between large and small. Medium is another word for the substance that something moves through. Light and glass, air and water, these are different mediums that light uses to move. Refraction happens when light moves from one of these to another, say from water to air. It's this change that makes light bend. You can run through a screen door much more easily than a wooden door. This isn't a science experiment. Please don't try it. Like you, the easiest things for light to move through are the ones that are clear or transparent. When something is transparent, it means you can see through it. Have you ever shined a light through a glass of water and then tried shining one through a glass of milk? The light shines clear and bright through the water glass. Can you see the light bend? Try filling a clear glass with water and then sticking a pencil in it at an angle, similar to what we just did. The light from the pencil will bend and it will look like it's made of rubber. So what is it like to be a bending beam of light? Have you ever pushed your way through a crowded place to get to an exit? You have to step and weave around people. You'll probably need to go in a different direction than a straight line in order to get where you're going. Once you reach the exit, you are free to move quickly and in any direction. Like you, light wants to find the fastest way through. In water, light has to move at an angle to get through. When it reaches the air, it will move in a more straight path. Science uses a number called the index of refraction to measure how much light speeds up or slows down when entering a new space. It measures that moment when you burst out of the exit and are free to move quickly. Some things can only bend so much before they break, and light is no different. But when light breaks, something beautiful happens. The best way to break light is with a prism. A prism is a glass triangle with long, rectangle sides that can split white light into different colors. Because of the way it's shaped, it will bend light and then immediately bend it again, making it break up into smaller parts, showing you a complete rainbow. White light has all the colors inside it: red, orange, yellow, green, blue, indigo, and violet. Each color bends just a little more than the last. Red bends the least and violet the most. So when light enters a prism and is bent and then bent again, the colors separate like a rainbow fan. But by holding a second prism up to the rainbow, you can put the colors back together into a single beam of white light. Picture a race with your friends. You move through a windy field, through a pool, across an open lawn, and then through a crowded building. In order to find the way through, you have to move in all different directions, sometimes slowly, sometimes quickly. That's what it's like for light to move through our world, just millions of times faster. Okay, now that you're at the end of the reading passage, you're going to go ahead and click here. You're going to answer 4 questions about that passage.